Friends, welcome to s.mathguru classes. Our main discussion is Jacobians. Now we consider Jacobians of implicit function. If implicit function given, that means x, y, u, v, these are mixed up. How to find Jacobian of the given function? So Jacobian of implicit function, the variables x, y, u, v are connected by implicit functions f1 of x comma y comma u comma v equal to 0. This is number 1. f2 function x comma y u comma v equal to 0. Number 2, where u v are implicit function of x y. Differentiating 1 and 2 with respect to x and y, we get del f1 del x plus del f1 del u del u del x del f1 del v del x equal to 0. If we differentiating equation number 1 with respect to x, then we get this one. So again del f1 del y plus del f1 del u del u del y plus del f1 del v del x equal to 0. This is number 3, this is number 4, and in case of f2 del f2 del x del f2 del u del x del f2 del v del x equal to 0. This is number 5. Del f2 del y del f2 del u del del y del f2 del v del y equal to 0. This is number 6 we get. So if we differentiating 1 and 2 with respect to x and y, we get these 4 equation. We consider 3, 4, 5, 6. First two are 1 and 2. Now del f1 f2 del uv into del uv del xy, what we get? For first we get, for this Jacobian we get del f1 del u and del f1 del v. Next del f2 del u del f2 del v into this del u del x del u del y del v del x del v del y. We get this one. If we multiplying these two, we get del f1 del u into del u del x plus del f1 del v into del v del x. This again del f1 del u into del u del y del u del y plus del f1 del v del y. So we get this one with this is this, we get this one. Again del f1 del u with this and del f1 del v with this. This one finish. Next you consider second row. Again you multiplying this one with this one with this. Del F2 del U into this one. Del U del X del F2 del V del V del X. This one finish. Del F2 del U into del U del Y. Del U del Y plus del F2 del V into del V del Y. We get this one. Del V del Y, just we get this. Now, from equation 3, del F1 del U del X del F1 del V del X. This one, taking this one on right hand side, we get minus del F1 del X. Again del F1 this from this, from equation 4, this means this one, and taking this one on right hand side we get minus del F1 del Y. We get this from 3 and 4 we get it. Again del F2 del U this F2 this, and taking this one on right hand side we get minus del F2 del X, and from this we get this one, taking this one right hand side we get minus del F2 del Y, and from this row we taking minus 1 common, from this another minus 1 common, so minus 1 into minus 1, and this will be del F1 del X del F1 del Y del F2 del X del F2 del Y. We get this, and this is minus 1 to the power 2. Minus 1 into minus 1, minus 1 to the power 2, and this can be written as this one. We can write del F1 F2 del XY. We can write this. So therefore we get del UV del XY del UV del XY, this is minus 1 whole square del F1 F2 del XY by del F1 F2 del UV. This is our formula. Del UV equal to del UV by del XY equal to minus 1 to the whole square, and F1 F2 del XY and del F1 F2 del UV. This is our formula. So we can use this formula. We can easily find if implicit function are given x, y, u, v mix up, then we use this formula and we can easily find the Jacobian. This is a formula. In general, the variables x1, x2, xn up to nth variables are connected with the u1, u2, un implicitly at f1 function x1, x2, xn, u1, u2, un equal to 0, and f2 function x1, x2, xn, u1, u2, un 0. F nth function x1, x2, xn, u1, u2, un equal to 0. Then if we get nth variables, the formula will be del u1, u2, un by del x1, x2, xn. This is minus 1 to the power n. Minus 1 to the power n del f1, f2, fn. This by del x1, x2, xn, and by this. We get minus 1 to the power. Our main first formula given only two variables x, y, u, v. Then we write this is 2. If we have nth variables x, y, x1, x2, xn, u1, u2, un, then we write minus 1 to the power n. this formula. So we can easily solve some problems by using this formula. Let's consider one problem. We want to solve one problem. This is if x² plus y² plus u² minus v² equal 0 and uv plus xy equal 0, prove that del uv by del xy, that means Jacobian uv with respect to xy equal to x² minus y² by u² plus v². We have to prove this. Now solution is start. Let f1 equal to x² plus y² u² minus v². We consider this is f1 and f2 equal to uv plus xy. We consider this. Now del f1 del x del x x² plus y² plus u² minus v² equal to, we differentiate partially with respect to x, that means y u v are constant. We get twice x plus 0 minus 0, this is twice x. Del f1 del y, then we get del y x² plus y² plus u² minus v². We differentiate partially with respect to y, only y variable, other constant. This is x² is 0, y² means twice y, this is 0 minus 0 equal to twice y. Next we find del. Now we find del f1 del u. Del u, f1 means x² plus y² plus u² minus v², and we differentiate partially with respect to u, then others constant, only u is variable. 0 0 twice u minus 0, this is twice u. Del f1 del v del v, this is x² plus y² u² minus v², this is 0 0 0 minus twice v minus twice v we get. So f1 is over. Next we consider f2. Del f2 del x del x uv xy. uv is constant, this is y into 1 y, because we differentiate partially with respect to x. Del x of x is 1, y outside. Del f2 del y del y uv xy, then 0 plus x into 1 x. Del f2 del u del u uv plus xy, this is v into 1 plus 0, this one v. Del f2 del v, then del v uv plus xy, this is u is constant, u into 1, del b 1, and xy constant, this is 0, this will be u. We get this one. Just we find details all of this. Now we find this del f1 f2 del f1 f2 by del xy. By definition of Jacobian, we get del f1 del x del f1 del y del f2 del x del f2 del y, and this will be del f1 del x, and this is twice x we get. Del f1 del y, this is twice y. and del f to del x, del f to del x we get y, and this one x. If we expand this, we get 2x square minus 2y square. Then 2 common, x square minus y square we get. So this one we get. Now again we consider Jacobian of f1, f2 and uv. Jacobian of f1, f2 with respect to uv. By definition of Jacobian, del f1 del u, del f1 del v, del f1 del u, del f2 del u, del f2 del v. We get this. And putting the ready-made values, del f1 del u, this twice u, and this is minus twice v. Del f2 del u, del f2 del u, this is v, this is u, v, and this one u. This one 2u square plus 2v square, and 2 common u square plus v square. We get this. Now del, our requirement this one, del uv del xy. So we can write only two variables we get uv, then this is minus 1 to the power 2. We get this, and del f1 f2 by del xy del f1 f2 del uv. We get this one, and minus 1 whole square is this, plus 1 we get, directly read plus 1, and del f1 f2 del xy we get 2x square minus y square, and del f1 f2 del uv, this is 2 u square plus v square, this one, and 2 cancel, we get x square minus y square u square plus v square. Therefore what we get, del uv del xy we get x square minus y square by u square plus v square. Hence proof. This is our proof. Very nice solution, very easy. I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel for getting new videos at the very beginning, then please subscribe my channel and click the bell icon. Thank you.